Okay, in lesson 10, we're adding mixed numbers. Now, when we're adding mixed numbers, one thing, if you rewrite this, this is actually 2 plus 1/2 plus 1 plus 1/5. And with the commutative property, we can change this around any way we want. So I'm going to put 2 plus 1 plus 1/2 plus 1/5. That way I'm adding my whole numbers and I'm adding my fractions. And we can see this one here ends up being 3 plus, now we need to add our fractions, which are 1/2 plus 1/5. Now, whenever we're adding fractions, unlike denominators, first thing we have to do is find a like denominator. And the first strategy I like to look for is see if we can turn one into the other. And what I mean by that is we're looking at our denominators down here. We have a 2 and a 5. So if I skip counted by 2, am I going to be able to get to 5? And that's no. So we would not be able to use this first strategy. Now the second strategy would be find the least common multiple. And what that means, if I list them up here, 2 and 5, and I skip count, going 5, 10, I can see that 2 is a multiple of 10. So because that'd be 4, 6, 8, and 10. So 10 would be our least common multiple. Now, this would also be the same multiple we got if we just multiplied the numerator and both denominators. And that's our third one, which is we call the smiley face. So I like doing that in that order because if you can solve it either using 1 or 2, then you don't have to do as much reduction if it's required. So, using the smiley face method, the first thing we do is we multiply the 2 and the 5. Now we're going to come up and circle the top left denominator, and because we're going to multiply that times 5, and then we're going to add our operator, and then we're going to go to the top right numerator, and we're multiplying that times the other denominator. And now we can see we have 5 plus 2 over 10, so it equals 7/10. So now we can replace that up here with 7/10, and we know our total answer is 3 7/10. Okay, number 2, let's go ahead and rewrite this. This is 1 plus 1/5 plus 3 plus 1/3. And we can put the whole numbers together, 1 plus 3 plus 1/5 plus 1/3. And we know we're going to add our whole numbers, we're going to add our fractions. So now we have 4 plus, now we're going to need to add our fractions. 1/5 plus 1/3. Now if I take my lowest one, 3, and if I skip count it, I cannot get to 5. So our first strategy of turn one into the other cannot work. The second one, we're looking for our least common multiple, 3 and 5. And we know that's 10, 15. We can see that our least common multiple is, once again, going to be the same thing as if we multiplied both denominators together. Doesn't always work that way. So we're going to end up doing strategy 3, which is our smiley face method, which is 5 times 3. And we're going to 1 times 3 plus, we got to put that operator in there, 1 times 5. So now we're going to end up with 3 plus 5 over 15, which gives us 8/15. So now we have 8/15 here. So we know our answer is 4 8/15. Under C, DME, we have 3 plus 2/3 plus 1 plus 3/5, which when we change it around is 3 plus 1 plus 2/3 plus 3/5. Now we know 3 plus 1 is 4. Now we're going to add our fractions, 2/3 plus 3/5. We've done this once before, and we know that 3 times 5 is going to be our closest multiple. And then we're going 2 times 5 plus 3 times 3, which now makes that 10 plus 9 over 15. So that equals 19 fifteenths. Now here we've got a fraction that's greater than 1, and we can tell that because we can take a whole out of it, which would be 15 fifteenths, and we would still have 4 fifteenths left. So that equals 1 and 4 fifteenths. Now we're going to put that up here, 1 and 4 fifteenths, which the total is now going to be 5 and 4 fifteenths. So 3 plus 5 sevenths plus 4 plus 2 thirds, which equals 3 plus 4 plus 5 sevenths plus 2 thirds. Adding our whole numbers together, we get 7. Now we're going to add our fractions. 5 sevenths plus 2 thirds. Now, we know 3 cannot turn into 7. We go 3, 6, 9, 12, 14, 17, 21. So, right off the bat, we know that we're going to end up having to go 7 times 3 here, using strategy 3 of the smiley face. Then we got 5 times 3. Put in the operator. 2 times 7. Which now gives us 15 plus 14 over 21, which equals 29 21st, which we can take a whole out of there, which is 21 over 21, plus we have to add 8 more to get to 29 21s, which equals 1 and 8 21st. So when we come back up here and add it with our whole number, we end up with 8 and 8 21st. Okay, so this time we have 15 and a fifth plus 4 and 3/8. So when we decode it, we have 15 plus 1/5 plus 4 plus 3/8. And now I like to rewrite it where I have 15 plus 4 plus 1/5 plus 3/8. That way we can add our whole numbers and then add our fractions. Our whole numbers end up being 19. Now we have 1/5 plus 3/8. And we do our smiley face. We know we have 8 times 5 and 1 times 8 plus 3 times 5, which gives us 8 plus 15 over 40, which gives us 23 40ths. So we have plus 23 40ths. So our answer is 19 and 23 40ths. Okay. Now on this one, we actually have 18 plus 3/8 plus 2 plus 2/5, which equals 18 plus 2 plus 3/8 plus 2/5, which allows us to add our whole numbers, add our fractions. We end up with 20. Now we have 3/8 plus 2/5. Using our smiley face, we know we have 8 times 5, 3 times 5, plus 2 times 8. This is going to give us 15 plus 16 over 40, which gives us 31 40ths. So when we add that to our whole number, our answer ends up being 20 and 31 40ths. Okay, Angela practiced piano for 2.5 hours on Friday 2 1/3 hours on Saturday and 3 2/3 hours on Sunday. How much time did Anne subtract during the weekend? Now, if we do a tape diagram here, and we know the total here, total time, when we split this up into 3, we know it was 2 1/2 hours on Friday, and we have 2 1/3 hours on Saturday, and 3 2/3 on Sunday. Now it says, how much did she practice during the weekend? Now, there's two different answers on this one. On the answer sheet for the homework, it actually counts Friday, Saturday, and Sunday as our weekend. Whereas I know some people would only count Saturday and Sunday as the weekend. So I'm going to go ahead and work both of them out. Now, I would only count Saturday and Sunday as a weekend, not Friday, but I'm going to go ahead and show both ways. So the first one, if you counted up Friday and, let's say, Friday, Saturday, and Sunday, that means we'd add 2 1/2 plus 2 1/3 plus 3 2/3. And what I would do first is I would add my thirds together to end up with 2 1/2 plus 5 3/3, which that's actually a whole. So now you got 2 1/2 plus 6, which ended up with 8 1/2 hours. Now that's if you're counting Friday, Saturday, and Sunday. Now if you're counting just Saturday and Sunday, you end up with 2 1/3 plus 3 2/3, which would end up being 2 plus 3 plus 1/3 plus 2/3, which would have been 5 plus 3/3, which ended up being 6. So we'll go ahead and put both answers in there. I would rather go with the 6 than the 8 1/2, but the answer key actually goes with 8 1/2, just in case you see something else. Matt says that 5 minus 1 1/4 will be more than 4, since 5 minus 4 equals 4. Draw a picture to prove Matt is wrong. Okay, so here I've got this, and I know that equals 5. And I'm going to go ahead and set these into singles. Here's 1, 2, 3, 4. 1, 2, 3, 4. Okay, there's 5. Now this one here, I'm going to break up into quarters, because it said that it's going to subtract 1 1/4. That means this here is what would be left. And I can see this would be 1, 2, 3, and 1/4, 1/4, and 1/4. Which would be 3 3/4. So, as you can see, it would not be greater than 4.